Conditional probability. Conditional probability is when you find the probability that one event occurs given that another event occurs. This symbol right here means the probability of A given B. And the probability of A given B, its formula is you find the probability of A and B and you divide by the probability of B. So if events are independent, then the probability of A equals the probability of A given B, and the probability of B equals the probability of B given A. That means that if events are independent, remember that one event will not affect the other. So that means that this probability of A given B, the B is not going to make a difference in the probability of A. And this one, the probability of A is not going to make a difference in calculating the probability of B. So that's why these equations make sense. So and then just to review, remember that the probability, if events are independent, the probability of A and B equals the probability of A times B. So now we have some new rules that if events are not independent, then the probability of A and B can be probability of A times the probability of B given A, or the probability of B times the probability of A given B. Let's look at an example. We're going to use the following results from a survey of students to find the following probabilities. Probability of prefers pizza. Now we have a total of 45 students here, and it looks like 22 prefer pizza. There's the 22 that prefer pizza out of the 45. Alright, for prefers cake, 25 out of the 45 prefer cake. That one can be reduced to 5/9. Prefers cake and hamburgers. So cake and hamburgers. So if they prefer cake and they prefer hamburgers, that's 15 students. So 15 out of 45. Which can be reduced to 1/3. Alright, prefers ice cream or prefers hamburgers. So prefers ice cream. There are 20 that prefer ice cream, and there are 23 that prefer hamburgers. But the problem is we're counting these 8 twice, so we'll need to subtract those out. So we'll do 20 over 45 plus 23 over 45, and then we'll need to subtract out the 8 that we counted twice. And that gives us 15 out of 45, which equals 1/3. Alright, prefers ice cream given that they prefer pizza. Okay, so prefers ice cream given that they prefer pizza. So we're only looking at those that prefer pizza. So that's this 22 right here. So out of those 22, 12 of them prefer ice cream. So that's 12 over 22, which can be simplified to 6 over 11. Alright, next is prefers hamburgers given that they prefer cake. So given that they prefer cake, well, there are 25 that prefer cake. And of those 25, 15 prefer hamburgers. So 15 out of 25. And that will reduce to 3/5. Alright, are the events prefers hamburgers and prefers cake independent? So to tell if an event is independent, then that would mean that the probability of A will equal the probability of A given B. Alright, well the probability, we'll say event A is hamburgers and event B is the cake. So probability for hamburgers, that would be 23 over 45. And then the probability of A given B, so we're only looking at those who prefer cake. So out of the ones that prefer cake, so that's a total of 25, it looks like 15 prefer hamburgers. Now as I'm looking at these two definitely are not the exact same. So there may be a chance that those who prefer hamburgers would feel differently about cake, or if you like cake, you might feel differently about hamburgers. So since these two probabilities are not exactly the same, then we can say that they're not independent, since there's a chance that one choice could affect the other choice. Now it's time to pause the video and complete the independent practice. When you're done, then press play to check your answers. Alright, a survey was distributed to a group of students that asked them what their favorite subject was. Use the following results from the survey to find the probabilities below. So one is the probability of math, and we look, and there's 30 out of the 100 who like math, so that would reduce to 3/10. Probability the student would be female, that would be 60 over 100, which would reduce to 3/5. The probability that they prefer science and they are male, there are 12 out of the 100, so that would reduce to 3/25. Probability that they like history or they are female, so there are 22 that prefer history, there are 60 females, and we have counted 15 twice. We only should count them once, so we have to subtract them out. So that makes 67 out of 100. Alright, so the probability that they prefer English, given that they are male. So out of the 40 males, 7 prefer English. And then the probability that they are female, given that they prefer science. So out of the 25 science, we have 13 females. And then are the events prefers history and male independent? Alright, so we need to get my page so we can see it all. So the events for history and male independent. So we'll say that history, that can be event A, male, that can be event B. So for prefer history, the probability that a student prefers history is going to be 22 over 100. And then we want probability of A, the probability of A given B. So now we're looking at just the males, and there are 40 males and 7 prefer history. So these are not equal, so that means that these events are not independent of each other. There's a chance that gender could affect how if a student refers a specific subject.